Good evening, ladies and gentlemen. This is ASQ webinar series. This is in partnership of ASQ Innovation Division as well as the ASQ Human Development and Leadership Division. Tonight, we're going to have a presentation about bridge engineering for innovation delivered by speaker Tracy Owens. Tracy is a business transformation leader who has led his employers and clients in developing a culture of continuous improvement to achieve near-term objectives and better long-term results. He's an ASQ fellow, and his two books, Six Sigma Green Belt, Round 2, and The Executive Guide to Innovation, are available on the ASQ Quality Press. Tracy is going to deliver a presentation about how projects sometimes fail. How can you give them a better chance of succeeding? Many of us are quality engineers. What principles from engineering principles? What disciplines can be applied in an innovation setting to help our chances for success? We will discuss automotive and civil engineering principles that, when employed to influence our project stakeholders, will help us achieve our objectives. Now, without further ado, I'm going to pass it to Mr. Tracy Owens to deliver the presentation. Thank you very much, Tracy.
Thank you, Jose. I am very pleased to be here. I'm calling in from the city of Columbus, Ohio, and I see we have participants on from several other places in the eastern United States and actually drifting into central United States as well. Thank you very much for being here with us. Very happy to have you. And the topic that I want to share tonight has a little bit of an evolution to it. And here's how it came about. We started, and by we I mean I and a few others, some names you might recognize, Peter Merrill, Ian Megaree, Kevin Posey, and Jane Keithley. We originally started the ASQ Innovation Division about 4 years ago, and we grew out of the ASQ Quality Management Division and needed to reach a wider audience. So concurrent with the launch of the division, we published the book that Jose referenced a minute ago, The Executive Guide to Innovation, which is available on Quality Press. And even that book now, having come out in 2013, just 3 years old, and it's already, dated. I mean, there's so much that's happening. There's so much new innovation in the world of innovation. But one of the things that we have always promoted, one of the things that we in the Innovation Division have always promoted is that innovation is a process. And like any process, there is an opportunity for improvement. If you manage innovation, you can get better at it. Instead of leaving it to your R&D department or to the CEO only and a few select leaders, if you manage it as a process that requires operators of that process, like anything else, that you can get better at it. It can be improved like any other process. But in order for it to be improved, it has to be documented, measured, understood, and who better to document, measure, and understand a process than the quality professional. In fact, innovation is not just a creative spark, and if you've watched any early ASQ TV episodes, we did get a chance to contribute to ASQ TV, and one of the things that we said was innovation is not just the spark. The creative idea, the light bulb that turns on, is not innovation. It's not innovation until it is realized, until it is brought to the market and enables new value to be achieved. Now, I'm not going to dwell on that because here's the evolution. The evolution to this material that I'm launching tonight, the evolution of this is precisely that. We need new material. We need new thought leaders. We need new contributions because the field is growing rapidly, and it's like quality was 25 years ago. Like quality was 25 years ago. There were a number of things that worked well in different parts of industry and government and education and healthcare, but they weren't widely shared. Well, now and for several years now, quality is well shared and well documented and well traveled. But innovation is not like that. So we are looking for what is the next breakthrough idea. I don't know if I have the next breakthrough idea, but I know it makes sense to me, and I wanted to share it with you. And here's where I came up with this. A number of us on this call and throughout the ASQ are quality engineers. And I'm going to launch a little poll. Let's see this. I'm going to launch a little poll. You see it on your screen. I want you to answer the question about what certifications you have, what ASQ certification you have. And I have on there just 4 choices. Maybe there's some crossover. But I have Green Belt, Black Belt, Six Sigma certifications, the Certified Quality Engineer, and then all other, which is a large field. I think there are 20 or 19 certifications available right now, and possibly the opportunity to earn an ASQ certification hasn't presented itself to you just yet. That is still out in front of you. So I just want to get an idea of my audience, what kind of players we have in the room. I do see that there are 10 people on the webinar right now. I do thank you for your attention. We are recording this to see if we can bring value to those who were not able to make it during this hour. So I'm seeing a few of the Six Sigma certifications popping in. I don't know if you're able to see this when I close the poll. I think it's share the results with you. But I do see 3 Six Sigma certifications. I see 1 CQE. I don't see any other certifications just yet. And then 4 who have not made the jump, not crossed over to the dark side yet. When you acquire that ASQ certification, it's really like a license to kill. I mean, you really got it. It's really something special. So 3 still haven't responded. Oh, we did have another entrant into the survey. Just give an answer on your poll. I'm kind of filling the space right now, but this should close in just a second. Meantime, I'm going to move forward in this. Engineering. Okay. When I was in college, I mentioned at the top of this program that I actually attended a college in my life. But my field of study was not any sort of engineering discipline. I have a business degree and a sociology degree. So I didn't study engineering. But I have worked with a lot of engineers over the years. And if any of you is an engineer, I have great respect for the education that you had to go through and the work that you have performed in that capacity, because it's really detailed. It's really detailed work. We have said about innovation that the spark alone doesn't deliver the value. It has to be executed. You have to make it happen. So a quality professional can be very valuable in that capacity, those who can really help you. But there's more. It's not just that the creatives come up with the idea and then pass it off to the executors. It's not just that the creatives come up with some wonderful idea, sketch it on the back of a napkin, and then pass it off to somebody else and say, make it so, make it happen. You take care of it. I'm off to the next idea. Because what can happen in that situation? What can happen in that? Those who created the idea, if they fully disengage from the concept, it's possible that their original idea may not be met. It's possible that changes may have to be made, and they will not be aware. Okay. So what I want to do is move through this, and I'm going to show you a couple of things that I'm going to share with you tonight from the world of engineering. As I mentioned, I'm not a practicing engineer. I'm not a degreed engineer. I am a quality engineer. Kind of what I was looking for in this poll was how many quality engineers there are, and there's at least one among the participants on this call tonight. So I want I'm talking to you. I'm talking to everybody. Regular old engineering, right? Engineering of any kind. When I went to college, and since then, there have been a number of people I've met who have been engineers, probably really excellent at what they do. I don't think I would be able to know if they were really good at what they did, because I don't know that world. But I have learned a lot from them. When I first got out of the Army, my employer was the Kenworth Truck Company, and I learned a lot about trucks. I learned a lot about truck engineering, not from the point of view of the person doing the calculations, but from the point of view of the person who was selling a product, who was selling a product that was either going to survive out in the unbelievably difficult oil fields of Western Siberia, or it was going to fail. So learning something about engineering was extremely important. So I want to relay just one really useful concept from automotive engineering tonight, and how I've been able to apply it in a process improvement setting, right? Because we talk about quality, process improvement, right? And then I want to pull the veil off, maybe the second part of this presentation, which might be the meteor, or the meteor, not meteor like a celestial projectile, but meteor like more beefy concept which is applied to innovation management, a concept from bridge engineering, civil engineering specifically toward bridges. All right. So before we do that, let us close our poll and see. It's fixing to close right now, but on its own in, I think, 4 seconds. We do have one unfinished response, 2 unfinished responses, and there they are. So let me see. Are you able to see these results? I don't know if I checked the right, there, share the results. So there they are. If they're on your screen, you can see that 4 of 12, Six Sigma Green or Black Belt. 1 of 12 as a quality engineer. 1 of 12 has another certification. Another 4 haven't achieved that yet, but I'm sure it's out in front of you, and the other 2 have not answered. So just 2 principles tonight in the time that we have together. 1 from automotive engineering, 1 from bridge engineering. Let me move first to the automotive engineering principle, and you can see in the picture on the teaser page that this is about 4-wheel drive. If you ever drew, or if you have ever seen a drawing of a car, an engineering schematic, or a picture, illustration of a car or truck, the axles, are denoted by a circle, which signifies the end of the wheel end at that axle, and there would be one on the other side as well. This is a 4-wheel vehicle, and if there's an X drawn, sometimes drawn as a cross, but most of the time drawn as an X. On that wheel end, that means it is powered. It means it has power. It's getting power from the engine and not just rolling along. Probably the car that you drive, probably the car that most people drive, will have a powered front axle, which was a development in the late 70s to keep more traction, better traction on the road, because the engine is heavier than the back of the car, to keep more weight on the axle that was powering the vehicle. Some cars still have rear-wheel drive. Some minivans actually have rear-wheel drive. And then a lot of vehicles have all-wheel drive. All-wheel drive, meaning the front axle and the rear axle are both powered. I'm not trying to explain the concept of all-wheel drive. I think most of the audience probably understands that when both axles are powered, you get better traction, actually significantly better traction, especially in foul weather. But think of this, the 2 axles, when they're both getting power, they both have to move at the same speed. And it's not a difficult thing. For a vertically integrated company, a company that does all of its own construction, it's not a difficult thing for that company to make axles that move at the same speed. But in a company that is a component manufacturer where it buys, like Kenworth Truck Company was, where it buys components from other companies and assembles them, buys the best components that can be bought on the market and assembles them into one truck, there can be differences. So what I want to talk about is the concept of all-wheel drive when both axles are not geared exactly the same. The number of teeth and the ratio of those teeth between the axle and the differential housing in the axle, from the drive shaft to the axle, is not exactly the same from front to rear. Can you picture that? It's not exactly the same. Now, it can't be too far off. If one ratio is 5 and the other ratio is 7, for instance, it's going to be too far off. Those are outside of a couple of percentage points of each other, and the truck's just not going to work. The car's just not going to work. But when they are close to each other, within a percentage point or 1.5%, it can still work. But there's a potential problem. Let me reveal this potential problem. If you have 2 axle ratios, right, the speed of the axle, and one is 5.19 and the other is 5.26, those are close enough to work. However, depending on which axle is actually moving faster, one of those axles have a faster ratio. So in this case, our vehicle, and I've made the very sleek, streamlined trapezoid in blue pointing to the right, indicating that the truck is moving to the right. And let's say, for instance, that the faster of the 2 axles is in the rear. It's in the rear. So that axle, not by very much, just by a fraction, is moving a little bit faster than the front axle. What can happen? Picture in your mind what can happen. A couple of things can happen. If that axle that's in the back is pushing the vehicle because it's moving faster than the axle in the front, if you have if you push your your 2 fists across the table and the back one is faster, it will eventually catch up to the one in front. But if you have that stiff blue trapezoid there, you can actually unsettle the front axle and it will start to skip across the terrain, thus minimizing the actual advantage of all-wheel drive. But what I want to focus on is when that green axle is pushing toward the orange powered wheel, the result of that is compression. It's compression. It's actually putting tension on putting compression on the system, and that's a bad thing. It actually is squeezing the vehicle closed until that front axle starts to bounce and pop and hop and skip across the terrain. There's compression, and compression in automotive engineering is bad. Compression in many places is bad. Squeezing somebody to the point of compression can be a bad thing. So if we flip that around, actually given the choice of two axle ratios, one of which is faster than the other, if I put the faster of the two axles in front, and this engineering information was given to me by Brian Lindgren at the Kenworth Truck Company, a very reputable, practicing engineer for many years. He said, I want the front axle moving a little faster than the rear axle. And he explained to me the reason why is because it actually stretches the system. The result is tension, different from compression. Compression, bad, fists hitting each other. Tension, hands pulling away from each other. And that's a good thing. It's a good thing because it lets the whole system expand. And actually you gain modest, very modest efficiency as well when the front axle is moving a little faster than the rear axle. If I explained that principle, probably over-explained it. But how does it apply in process improvement? Remember, the green is faster and the orange is slower. Let's look at a process. Let's look at a quality process improvement. Say you're running a Kaizen event or you're working on a process improvement project, all right, and you want things to work faster. The thing that's in front, we want to move faster than the thing that's in back, right? That's what we're explaining this automotive engineering principle. Another possible example before I get to the process is a street filled with traffic lights. And you've been on city streets that have every block or every 2 blocks is a string of red lights. And when you're lined up at the beginning of that street and all the lights are red, if the one right in front of you turns green and you accelerate toward the next one, which is still red, you might end up having to stop again before that light turns green. Now, if they're well timed, maybe it's timed so that if you hit exactly 25 miles an hour right when you get to the second light, it will also turn green and not tempt you to tap your brake pedal. But if there are more cars on that street, some cars that were already parked at the second light and the third light and the fourth light, what you're going to have is compression. If the green light nearest you releases, or the red light nearest you turns green first and releases you, you'll have compression in the system as you work your way down the street. You've seen this. I'm sure you've seen this on city streets. On the other hand, if the light at the far end turns green first, right? You've got 7 or 8 traffic lights in a row on this city street. If the light at the far end turns green first, releasing the cars at the far end, followed by the penultimate light and all the way back toward you, all those lights are green now. So all you have to do is roll down that street and continue on uninterrupted, no compression, stretching out the traffic until it is time for them to turn red again. So my principles, the principles I'm explaining here: give the front axle more speed, release the later lights first, the later part of the process. These are the same kind of idea. And what I want to suggest is this, and I would look for, invite arguments to describe this. Maybe something in the world of tack time, Laura Gibson. I don't know if that's, if the science is against me on this, but it seems to make sense, and I've made it work in several places. Fix the second half of the process first. Remember that green was faster and orange was slower. So suppose I have a process. I've got a process that has 3 main steps. Now, of course, you break this down into more detailed process map and a swim lane diagram and a SIPOC where needed. But if I have order entry, placing the order, and then order fulfillment after that, and then later on customer support, which I won't examine in this discussion. But if I have order entry and fulfillment, and both are dysfunctional, both are not working as well as we would like them to, or as well as our customers would like them to, as proven by our voice of the customer and our voice of the process monitoring data. If I get the team together and we fix order entry first, the green, we make it faster, we make the order entry process faster, what's going to happen? We're going to push, once that's fixed, we will push more orders into a fulfillment process that doesn't work well. A fulfillment process that doesn't work well. The result, once again, is going to be compression, and even further, the customer experience ultimately will be bad. The customer will be unsatisfied because their last taste of the process will be the dysfunctional fulfillment subprocess. Instead, what I need to do is fix order entry last. I need my pace setter to be the process that is later. I need to build the infrastructure in order to accommodate a better order entry process. Do I have a picture of this? I don't. If I instead turn the fulfillment process green first and make it ready to accept a better order entry process, if I have the discipline, if I invest the time now, like so much of lean thinking, invest a little time now, and you're going to reap the benefits later. So my assertion is to do that. Now, another way to look at this is with a sequence of quality tools, sequence of process improvement tools. How can you decide what part of the process needs to be fixed first, right? How can you decide what part of the process needs to be fixed first? And this is a set of tools that I have facilitated many times. A number of my friends have facilitated these as well, a lot of quality practitioners, and they work really well together, right, to build this sequence of tools by collecting ideas from people about what parts of the process are broken, and then you make the affinity diagram. I mean, I know many of you quality practitioners have done this, where you get the sticky notes, the individual ideas, and stick them on the wall and then move them into affinity groups. Well, that's not the end of the affinity diagram process. Once those affinity groups are separated, they need to be named, some sort of name of what that theme is. What is that problem? And then when you take those 5 themes, and any of those, the peach, the yellow, the green, the gray, or the blue, could have been labeled A, B, C, D, or E. And then you build with, I think the official name is interrelationship diagram. We call it the clock diagram, where you put it on the wall and then evaluate the relationship between every pair of variables. The relationship between A and B, the relationship between A and C, A and D, A and E, and then all of those. Let me explode this out a little bit. You look at the relationship between those variables, and then once you have all and there's a combinations formula for how many total areas will be, or arrows will be up there, but every theme is going to have n-1 number of arrows, either coming in or coming out. The arrowhead goes to the item that has to be fixed first. In every pair, you put the arrowhead toward the item that needs to be fixed first. And you can use give the front axle more speed in this scenario. And then you count the arrowheads and label them next to the item. So in this case, B and D each got 3 arrowheads. They each got 3 arrowheads. So which one goes first? The one that won the head-to-head. You can see that the arrow between D and B, the arrowhead goes toward B, meaning that B has to be fixed first, so B wins. And then what you do is take B and then D, and the same thing with A, E, and C, and you can construct what's in green here at the bottom is extract the sequence diagram, and that's what needs to be first. So this is a principle. Some of you may have practiced this before, but deciding what to fix first can be an important first step in managing a portfolio of projects. Which one shall we fix first? And there are several reasons why you might choose one over another, and my position based on 4-wheel drive is to give the front axle more speed, fix the second part of the process first. We will, Jose and I will open this up to questions later in the, I think we'll open this up to questions, or we may have to use the chat panel or the Q&A panel on your screen to be able to do that, and we certainly will want to entertain your questions. We can see, anyway, I'll look for questions. So I'm going back. I'm going to go back into the material, and now I'm going to talk about my bridge engineering topic. Okay, I'm moving out of automotive engineering into civil engineering, a discipline of which I am also not a practitioner, but what I have learned about from the civil engineers with whom I've worked, and specifically my father-in-law, Charlie Gorman, who worked 37 years with Bethlehem Steel building bridges. And this is a concept that actually was developed, I shouldn't say was developed, it's not some like grandiose passive voice. It was me, and I conceived this idea, but I had some help. I had some friends help me do this. My friends, a few of them are on this call now. I've got Laura Gibson and Tammy D'Alto on the call with me, and a few others went with us in the Dayton section of ASQ. And if you're in the Dayton section of ASQ, congratulations, because Dayton section is really doing terrific right now this year, with a lot of enthusiasm. And Dayton Ohio section was just awarded the 2017 Innovation Conference. So Dayton, Ohio, section of ASQ will be the host for the Innovation Conference in October 2017. Please look for more information on that in the coming months. So what we did one day in looking for new ideas, new innovation ideas, and new membership ideas was we walked a labyrinth. And if you haven't walked a labyrinth, it is not goofy. It's not, like a divining rod or looking for runes. I mean, it's not. There's nothing that there's anything goofy about, any of those disciplines, any of those items. But it's not far-fetched or harebrained. It actually is a very soothing experience. And it was when I learned about it, and Jane Keithley is on this call as well. Jane and I learned about this at the Pittsburgh World Conference back in 2011, ASQ World Conference, where the program committee put a labyrinth with masking tape on the floor. And a labyrinth, if you have read anything about it, or if you know anything about a labyrinth, you know that it's like a maze. The word that pops into mind might be maze, but it's a maze that has no choices. There are no choices to be made in a labyrinth. It's just one path in and one path out. So you use the labyrinth as a way to generate new and creative ideas, because what you're able to do is effectively shut off your left brain while you're in the labyrinth, because there are no rules that you have to pay attention to. There are no rules that you have to follow. All you have to do is keep your eyes on the road and keep walking forward. So you look down at the path, your brain says, no problem, I can follow this path, and your left brain is able to shut down, and your right brain is able to flourish, teeming with new ideas that you may have thought of eventually, but they'll certainly be accelerated and possibly conceived where they would not have before. So we walked a labyrinth looking for new ideas, and it occurred to me in that labyrinth that sunny day back in June that innovation is like building a bridge, and that might sound trite. It's like building a bridge from the present to the future, and that alone, is not entirely revolutionary. But the idea that I thought of was, what if during the construction of that bridge something changes? What if during the construction of that bridge you either have to change direction, or the materials, and the conditions turn out to be different than your assumption? Now that is a parallel argument. That you do find in the execution of innovation projects and initiatives. You do find that it's not always a smooth path, not always smooth sailing. So I explored this topic a little bit with Charlie, my father-in-law, and he gave me a couple of ideas. And one of them was this, that you've got two types of applications for steel members. Now, this is Charlie's point of view. He's a steel guy, right? So a truss bridge like the one pictured on the screen, and you've probably seen a lot of times train bridges have this truss construction to them, this steel truss. I think fewer automotive bridges, and certainly fewer pedestrian bridges have a truss construction, but a lot of railway bridges, and there are overwater road bridges as well that have a truss construction to them. But all of these steel members, and by member I just mean like an I-shaped beam. I mean, if you know what an I-beam looks like, it's got a flange on the top, flange on the bottom, and then the web is the thick part in the middle that's usually vertical. Those pieces will either be stretched or squeezed when weight rolls across that bridge. When some heavy vehicles, or any vehicles, roll across that bridge, there's going to be a flex. That bridge doesn't stay perfectly motionless. There will be some flexing. So what I want to ask you to do, if you have a pencil, do you have a pencil anywhere near you? Wooden pencil, or a thin, like a Bic pen. A Bic pen, or plastic barrel pen is a real good example of this. If you've got a pen, plastic pen or a pencil near you, just put it in your both hands. Put your both hands in front of you, and put your fingers on the top and your thumbs on the bottom. Your thumbs right side by side to each other, and kind of give it a push, not to the point of breaking. I don't want to damage your favorite pencil, but if you could push down on the outsides with your fingertips and up in the middle with your thumbs, you're going to see that pen is going to flex. It's going to curve a little bit. That's nothing new. But here's the thing that was new to me. Maybe you already know this, but this was new to me. When you push out with your thumbs and you see that curve, okay, watch that curve, because the part of the pen that is on your thumb side that's curving inward, the molecules, I'm not kidding, the molecules on that side of the pen are being compressed. They're being compressed. They're being squeezed closer together. Conversely, at the other end, the outer end, it's probably the end away from you, but it is on your fingertip side, that's being stretched. It's actually elongating the littlest bit. And in some of these pens, it seems like it's elongating a lot. Some of these plastics, these plastic resins can flex a lot. And they're separating. That is known as tension. They're putting tension. You're putting tension on those outer molecules. So if that pen in your hand were equivalent to a steel member on a bridge, your thumbs would be pushing down. Your thumbs would be pushing down from the top of that bridge, like where it says truss on my screen. That's where your thumbs would be. When a heavy weight rolls across that, and you'll see that the green member on the top will be where your thumbs are, and it'll be getting squeezed together. And the red members across the bottom, and even those diagonal members, are actually going to be stretched when a heavy weight rolls across that bridge. I hope I haven't over-explained that point either. But that was interesting to me. That alone was interesting, that there are tension members and compression members. But it gets better. It gets better because I brought up to Charlie this concept of the bridge and how things can change during construction. He said, oh, yeah, we absolutely knew that, because during the construction, you start from one side and you go to the other. Or if you have, false works under the bridge, you have to, build out from those. But at some point, pieces of steel are hanging in the air, unattached to something at the other end, until you make that connection. So during construction of the bridge, it is possible that a steel member, I-beam, that ultimately is going to be used in a tension application may actually have to serve as compression while it's being squeezed during construction. I would never have thought of this. And the same way, compression member, a member that is ultimately going to be used in a compression application, may be stretched during the construction. Until the bridge is done, it may actually be stretched. Well, there's more. Those two types of members, compression and tension members, they're actually built differently. It's not just the same beam. It's not the same I-beam that's used in both of those settings. Compression members are more stout. They're more sturdy. They can handle more pressure. Whereas tension members don't have to, because stretching them is not as severe a test of the steel as compression is. So the lesson during this in bridge construction is that a compression member, if it has to handle tension, that's usually not a problem. But a tension member, if it has to be used in a compression setting during construction, will likely have to be bolstered by some additional support, right? Because a tension member alone may not be strong enough to handle compression. This was fascinating to me. I hope it's not, coming out unintelligibly out of my mouth. I hope it's making sense. But let me apply this to an innovation setting. Okay, the principle that I'm talking about here in this beautiful, incomplete truss bridge, where those members that ultimately will be stretched are being compressed. You prepare for the final result, sure. Build your design, build your bridge design or your innovation project to prepare for the final results. Definitely, we want to know, what it's going to look like at the end, and that's what the sketch on the back of the napkin, will turn into. It'll turn into a good plan for what we ultimately want to achieve. But you have to prepare for the during also, right? And probably, some of us are intuitive about this, saying, oh yeah, during this transition there might be some grumbling. What can I do about it? Well, look at it in terms of compression and tension. Compression takes strength. If somebody's going to be in compression, it takes strength. It takes strength. It takes fortitude to be able to withstand the squeezing, the compression during the transition. And tension, if something is going to be stretched, it could be a good challenge for the people on your team, or for the even the organization, or the organizational culture. Can be a very good challenge. So what would we do about that? Innovation, we've been saying for years, Jane and I and others have been saying that there are really two phases to innovation management: coming up with a creative solution, something that's new, and then executing it. Because if it's not a creative solution, if it's not something new or adapted or new to this world, it's not really innovation. There is a whole world of improvements. There's a whole world of improvements. You've made many, I've made many, where there was nothing innovative about it. We just did the work better. We used some lean techniques, or we did some root cause analysis, and we made things better, not by innovating, just by working our process more effectively. So innovation, just to be defined as innovation, it's got to take something new. It has to be something new. I mean, just pick the word apart. In nova, meaning new out of the Greek, Sean, meaning putting it into action. So you have to put something new in action. So to create a solution is important, but it's not enough. It's not the end result. You still have to execute that plan for the idea to become real, and that's when value is delivered and when it's innovation. Creativity starts the process. Planning is also required, and we, as quality professionals, play a really important role, not just in execution, but also in creating a solution. I mentioned the labyrinth. We can help idea generation. We can help idea generation by putting a process in place and by actually putting restrictions on a group that limits the functioning of their left brain, so their right brain, the creative, the abstract, random side, can really flourish. All right, so let's keep that in mind. We play a role in this. So how can we turn it into something real? Well, we also have tools that we use, and we've learned them for years. Any of the Six Sigma, I asked about Six Sigma certifications at the beginning of this as well. And any of the Six Sigma practitioners, you've learned some of the change management tools and techniques as well, and several other disciplines, change management. And one of the tools that we have often used is stakeholder analysis. How do the people who are involved in this process, or who could be impacted by this process, how do they feel? How do they feel about this change? Do they embrace it? Are they opposed? And a stakeholder analysis is a very common tool, and what I've built here is just a simulated stakeholder analysis with the commonly occurring columns that would be found in a stakeholder analysis. Who is it? What's their function? Their current position regarding the change. Are they positive, opposed, or neutral? And then the desired position. Where do we need them to be in order for this change to be successful? And wherever there's a gap, neutral to positive, opposed to neutral, we have to take action. Some action needs to be taken in order to win them over. And not only that, wherever there is positive support, or at least neutral support that we need to maintain, we must not neglect those stakeholders either. So in this particular example, somebody positive, keep them engaged. Who else can we use? Could we use Donna to influence Reggie in this case, for instance? But a stakeholder analysis, great tool, very helpful tool. It's often looked at as before and after, their current position and where do we need them at the end of this process. Is there more? Is there more that we should be looking at? Like, how much stress will this change, will this transition put on them? And how can we use these players more effectively during the process? So what I've added, and you might not want to call it this, but what I've added to the typical stakeholder analysis, and I'm going to build this slide a little bit, is the tension compression chart, TC chart. And what it does, it adds a section. Now you can see I've just collapsed their position column. I mean, not the position, but their function column. I still got the same current position and desired position, but during the project, is there some way that any of these stakeholders, or each of these stakeholders, might be stretched or compressed? They might be, let's say, stretched or squeezed. How about that? Instead of tension and compression, Laura, we could say stretched or squeezed. Stretched meaning we're going to ask them to do more. We're going to actually ask them to do more. We're going to put more work on them, or I got to give them a chance to spread their wings a little bit. For instance, Donna and Reggie, since they're opposed, not opposed, since they're not opposed, since they're positive, maybe we can use them a little bit more. We can put some tension. We can stretch their capabilities and use them a little more. And then some we may actually want to. We may find the need to compress them a little bit. We might want to, I don't know, slow them down somehow? I mean, is it possible that somebody can move too fast? Is it possible that somebody in either a process improvement or an innovation project can move faster than everybody else? You've probably seen that where somebody says, I am ready. I am chomping at the bit. I am ready to make this happen. Let's go. I'm not waiting for anybody else. Hold on there, Geronimo. Well, let's compress this a little bit. Let's take our time a little bit. So the TC chart is like an added element to my stakeholder analysis. You might call it stretch and squeeze or whatever. But each stakeholder, how do we need them at the end? Like, what's the design for the bridge when it reaches the other side? But also, what's going to happen during the process? How can we use them best during the process to make sure that we all stay on pace, together? That we have given people a chance to shine and given others the chance to, well, frankly, slow down. So this is something that I've used. I'd be interested if anybody has used something similar to this, or if you feel like it might have some application in your world. I am moving on to a concluding slide, but it's going to take a couple minutes for me to go through. And I have my email address there at the bottom, and I do invite you to send me any thoughts that you have on this topic as well, because I would love to expand this topic a little bit more if I can. I have a few other ideas, about engineering topics, because engineering, to me, here, let me clear the slide first. The speed of the process depends on the pace setter process. Now, that's nothing new. As quality professionals, you understand the theory of constraints, and there's always one part of the process that is either a bottleneck or it's the part of the process that is, along the critical path that determines the overall time for the full process to be executed. The success of the project also depends on the people who are involved. It's the people who are involved in this, and I've turned this, I don't know if I've done this nimbly or not, but turn this from engineering towards stakeholders, using engineering principles to help with the design, to help with change management. But the principles that I shared with you tonight were: give the front axle more speed, a faster front axle, move the work into a good process, not a sluggish one, meaning fix the second half of the process first, fix the later parts of the process first. And I went real quickly through the affinity diagram, clock diagram, and sequence diagram approach that I've found very valuable, and we've been able to teach that to others who've also been able to employ it. And then the second was the topic of tension and compression in steel bridges. Each member, it's funny how a steel member of a bridge, and then we have members of our teams and our project team members. I don't think that's a coincidence. I think there's something to that. How each of those members of the project team, ultimately we have a design, or we have an idea of how the organization is going to look and how the organization is going to function when the project is done, when the innovation is in place. But how about during the project? Have we given enough thought to that? And is there a way that we could take some compression members, some people who are going to be strong in this, and see if we could stretch them a little bit during the project? And on the other hand, some of those who we think are possibly moving a bit too fast, how can we keep their enthusiasm but not let them get too far in front? Now, I do invite you to send notes to me or to anybody who you might know in the Innovation Division. If you are not a member of Innovation Division, this is not a full-on attempt to recruit you in, but we would love to have you, because we are looking for new ideas. We're looking for fresh new ideas. And if bridge engineering for innovation, is resonating at all with you, I would like to talk with you more about it. And if it's not, give me something that is, and don't give it to me. You come into Innovation Division and we'll give you the spotlight. We'll give you the spotlight. Human Development and Leadership Division, members of HDNL. We want to learn more from you about what works in your world and what, how we can help you to innovate and how you can help us, to innovate. We help each other. So we're always looking for a new idea and a new way to employ it, a new way to reach people and provide value for our members. So I'll leave my email address up there. I am going to open the the Q&A screen just to see if any questions have been typed into that. I don't see any at the moment. Please definitely type into that. I'll open the chat panel as well. I think, Jose, that we muted all the lines. I haven't heard anybody speaking at all into the broadcast. But if it's possible to do that, it's 12 minutes till the top of the hour, and I am interested in any questions that anyone might have.
Hey, Tracy, thank you very much for delivering the presentation. Definitely very informative on your approach in using these quality tools into the innovation process. Regarding your question, it would be possible to unmute the lines, but I'm pretty sure it's going to cause some troubles assigning. But if any participant could raise their hand or put something on the chat or Q&A section, we'll be more than happy to answer those.
I don't know if it shows while typing is happening or only when you click submit. So maybe we'll just wait 30 seconds and see if any questions pop in. Okay, no questions are popping in. I will I'll stop. No need to go. Oh.
Tracy, there are a couple of chat questions. I think participants have figured out how to raise their questions. So let me mention the first one. It is from Emily Sargent, and basically says, "This seems directly applicable to my music background. My degrees are all in performance, and I look forward to thinking through how to make that connection as well." So that's a comment. Thank you, Emily, for bringing it up. There is another Q&A from Robert Alba.
Most organizations, I got the question from Robert. Most organizations are like an 18-wheeler, with each of the wheels moving at slightly different speeds. Yes. As you know, there tends to be one set that moves much slower than the others, a bottleneck. How does this focus benefit more than just focusing benefit more than just focusing on the bottlenecks? Yes, that's a terrific question, because usually, I'm sorry, let me say the question again just to make sure that I was kind of reading it to myself. Let me ask it again. Most organizations are like an 18-wheeler, with each of the wheels moving at slightly different speeds. As you know, there tends to be one set that moves slower than the others, much slower, a bottleneck. How does this focus benefit more than just focusing on the bottlenecks? And it's good. You give a lot of attention to those bottleneck processes. I mean, that's the place where you look first. You evaluate the time, you monitor the speed of the process. Defect rates can contribute to that as well. But even in reading the goal, the goal, the bottleneck, you find it and you squash it. You figure out how to isolate it, and then you move on to the next bottleneck. But only that bottleneck is getting the focus at any given time. What I like to look at, and I don't know if a TC chart is exactly the best way to do this, but it works for me. What I like to look at is the whole environment and say, now, if I look at this whole network, this whole 18-wheeler as a spider web, if I pull on one part of the spider web, the whole thing is going to flex. And if the part of the spider web that I pull on is the bottleneck at that time, what effect is it going on to have on the rest of the system? So by looking at my actually, first automotive engineering principle, that give the lead axle, the front axle more speed, if I can if I can fix the end of the process first, then I'm feeding good work. I'm feeding good work as I continue to build the early parts of the process into a part of the system that is working well. So by squashing a bottleneck and paying attention to the bottleneck in the process, that's great. But what happens next? What you get is that accordion effect. You get that what is it? The golf ball through the garden hose. You know, the bottleneck is just going to continue to move. So is it possible to actually, instead of just your theory of constraints, you know, focus on the bottleneck, to actually look at the whole system and to look and see, can I engineer, can I influence the overall system by choosing which part of the process to work on first, not necessarily the bottleneck in the process. And I know that might be sacrilege to my, you know, lean practitioner friends on the phone, but it's not always it might not always be the most important thing to focus most urgently on the bottleneck first. I guess that's part of what I'm saying, Robert. I'll move on to another question from Jane Keithley. In the stakeholder chart, how does the idea of compression is stronger translate to people on the team? Well, in the stakeholder chart, thank you for the question. In the stakeholder chart, you've got people who are, well, I think, I don't know if indifferent is a category, but usually it's either positive, negative, or opposed. Positive, negative, or opposed. But there's more, because there are people who are, what are the extra categories? You got the vocally in favor and the passive. What are they? I can't think of the words. Vocal or active opponent, passive supporter, and active supporter. I think something like that. And those people, that depicts their approach. That depicts only their approach. But it doesn't really describe the leverage that they have in the whole organization to make more parts of the organization tick. That levers section at the end of that is what I really expand into the tension and compression chart, or the stretch and squeeze chart. You can take somebody who is passively supported. Taking somebody who's actively or vocally supportive and turning them into a cheerleader is not really a challenge. I mean, you can have them make videos for you or stand up and make speeches for you, but they might not always be the most influential voice just because they're the loudest voice. Right? So no one is omitted from the opportunity to make a difference in a stretch and squeeze or in a TC chart. Everyone, you know, there's a chance that everyone could play a role. I don't know if that's helpful. Is there a question, Jose, that's sent to host only that I'm not seeing also?
Hey, Tracy, I think those were all the questions. Yep.
Okay.
Yep, that was all.
Okay, great. All right, thank you. I want to thank Jose. Thank you for arranging this between Innovation Division and HDNL Division. You made it very easy for me. Thank you very much.
Thank you, Tracy. And just to remind the participants, the recording of this video is going to be available at the ASQ Innovation YouTube channel, as well as in the Human Development and Leadership website. So if you would like to go back or maybe invite other people, co-workers that may be interested in learning more about innovation, that information is going to be available there. So Tracy, again, thank you very much for delivering this wonderful presentation. And well, hope you see you next time on the November presentation. This is going to be November 14th. I'm going to be sending some additional emails inviting the participants or the people to join. All right. So thank you very much, everybody, for joining. Have a good evening.